Hey there, and thanks for watching. So over the next few minutes, I'm going to share one of my colleague Arturo Parada's recent models, our data center development model. I'm also going to talk through some of the key differences between modeling a data center versus, say, just a more run-of-the-mill industrial warehouse or distribution center. So let's get started. Now, as with all of our models, you'll start with a version tab. This will orient you to changes that the author of the model has made. Again, Arturo created this model. The history behind our, call it, content around data centers is while myself and Michael have had some interaction with data centers, I underwrote a few years ago, nothing that would classify us as an expert. And so we hadn't released a data center model until Arturo on our team I'd done a series of consulting engagements with several data center developers and built a proficiency around this. So we tasked him with creating a model that could be shared with the a.cre community. And from that, you have what is right now beta version 1.2 of this model. Again, on the versions tab, you can see updates that Arturo has made. Now, as with all models, you'll find an underwriting tab, or most of our models, this underwriting tab, where the great majority or all of the inputs of a model live. Blue font cells being those input cells. Let me first cover, before I walk through Arturo's model here, some of the key differences if you're unfamiliar with data center modeling. The first primary difference is that with this sort of underwriting, rent is generally quoted as a per kilowatt or a per megawatt of total load, rather than per square foot or per meter, as in the case of most leases. And that's because the revenue associated with the tenants in this space are more driven by the available power that is made available to these tenants than necessarily the size. And again, that's because these centers are generally used to house, say, servers, and those servers are going to serve purposes like cloud computing or AI, artificial intelligence generations and or training, right? Those sorts of uses. And these servers are relatively small, and they come in these racks. And so the amount of space that is stored here, it matters a bit less than the amount of power that these consume. And so Arturo, to help you out, added some of these key notes here where he talks through IT load, total facility power, white space versus gray space, power usage effectiveness, and then redundancy. And these are key, call them definitions that are unique for data centers relative to some of the more traditional property types that you'll see us underwrite. But again, the primary difference, or one of the primary differences, is that rent is usually quoted on a per kilowatt or per megawatt basis, kind of rentable power rather than rentable square footage or rentable space. The next big difference is your cost structure. So while in traditional industrial, you have pretty simple OpEx, you do have maintenance, you've got insurance, taxes, there's some utilities, but generally, as a percentage of total rent, is lower. These are power-intensive operations with high variable OpEx, primarily driven by electricity costs, cooling, network infrastructure. And so you need to model this concept of PUE, power usage effectiveness, in order to forecast the energy cost per kilowatt of power. And you'll see that there's just a PUE input there. And PUE, again, is the total facility power divided by the IT load. And so you want this as close to 1 as possible. But that's going to be determined by the facility itself. And so like how much power are you paying for from the grid versus how much power are you delivering to your tenants? So if, for instance, we put 1.5, that's for every 1 megawatt of IT load, the data center draws 1.5 megawatts from the grid. Closer to 1, the more efficient your use of power is. You're also going to see that in these centers, you have heavy infrastructure, electrical, mechanical, cooling, network systems, both upfront as well as ongoing capital expenditure load. That contrasts with, say, shell construction in an industrial warehouse, which is low cost, low tech. It's about storing goods within a space, and high ceilings, wide column spacing, such that you can store a lot of space in an industrial shell or box. These data centers, while space matters, certainly the big major upfront capex around the components that make these servers run. The implications of that is you're going to see a much higher, first off, upfront cost. These are incredibly expensive facilities in most cases to build, and so high capital intensive. The types of operators and capital that are doing these are generally larger scale, and as a result, you're going to have much higher rent numbers, including reimbursements to cover a high operating expense load, together with the cap expense that you'd expect in something like this. The next is around lease structures, right? So in industrial, you got to have your typical simple triple net leases. Now, there's some complexity when you get into third-party logistics firms, where those can tend to be shorter-term leases and sometimes have termination clauses depending on who their customers are, right? When they're providing third-party logistics services for customers. In this case, these are hyperscale leases that can run 10, 20 years, often with some pretty complex service level agreements. And when I say service level agreements, these are like formal contracts between the service provider, so in this case, the data center operator, or our tenant, if we own the box, and their customers. And their customers are often like hyperscale cloud providers, maybe AWS, Microsoft, Google, or large enterprise tenants. In the case of AI, say an OpenAI or Anthropic. And these these service level agreements have some performance metrics that often are key. And again, you're going, okay, well, what do I care about a service level agreement with my tenant outside of, hey, my tenant needs to meet their obligations? Well, some of these obligations are on you. Things like uptime guarantees. Well, uptime guarantees around internet is a function of a number of things, but power being one of them. And so if you're not delivering power to the facility, then uptime is going to be an issue. Uptime is an issue, then these service level agreements run into issues, and therefore, right? Another is around, say, latency. That's how quickly data can be transmitted. Available power, cooling, and so there's going to be an expectation around redundancy. And then there's remedies if these metrics aren't met, whether it's rent credits or even termination rights. And so as an owner, understanding those service level agreements and ensuring that you're doing your part is going to be pretty important. And then finally, we see currently a pretty big discrepancy, or a meaningful discrepancy in cap rate between just our industrial distribution centers and data centers right now, given the high demand. And we're sitting here middle of 2025, the high demand for data centers, you're seeing pretty tight cap rates for data centers. That's going to change though, when, who knows? But certainly the cap rates for these data centers relative to the risk, right? We often think of risk in terms of, okay, a high capex is considered risk. Relative high uncertainty around leases means risk, and usually higher risk means higher cap rates. In this case, given the AI trends that are going on, you have tight cap rates, and so there's a cap rate relative to risk thing that is a bit out of balance. Just my opinion, and so something to watch. You might be underwriting really tight cap rates, but if you're looking out 10, 20 years, you do have to wonder how long these cap rates can continue to be as tight as they are. With that said, let me walk you through now the model itself. Again, if you're familiar with a.cre models, this will be quick and easy. If you're less familiar, focus in. But we break up our models into these sections. Let's call it an investment description. Each one of these blue font cells are a required input. So do not expect any input that is blue font in this model to be real. These are simply placeholders. It's your job to change those. The hypothetical deal here is actually in Central America in a free trade zone called Panama Oeste. It's a free trade zone I'm fairly familiar with, and Arturo used it for his placeholder. But again, it could be really in any country. And you have kind of your typical metrics. You can toggle between square footage and square meters. And you've got building size, land area, and so forth. You again have this PUE concept. Again, the closer to 1 you get, the more efficient it's going to run. I'll just leave it at 1.5 as a placeholder. From there, we get into investment cash flow. So these are your development period cash flows, your uses of capital, and then we'll also model sources of capital. So here you're going to put in line items like what your land cost line items are, when those uses begin. So land often is in simply period 0, month 0 of your analysis and ends. So you have your start and your end. And so if a line item is going to be used over a longer period of time, and you'll get this makes more sense in hard cost, but in land, generally all of it happens at one time. And in this scenario, it all happens at the very beginning of the analysis. And then you have 2 methods for modeling this out, straight line, or 3 actually, straight line, S-curve, or detail. It'll make more sense when we look at hard costs. So again, we have a start and an end. And then we have either S-curve, that's a normal curve, normal distribution curve, where early and later in the period, the less the dollar amount or the amount is, the more middle of the curve, the higher the amount is. So you look at something like site work and civil infrastructure. Let's take that to 12. Let's use an S-curve. This is 10 million. You'll see in the early periods less, and then it ramps up to the middle periods being max, and then ramps back down. And you can adjust that curve on this S-curve reference page here. So right now we're using just a 6 in steepness. As I come down close to 1, it becomes almost straight line, meaning every period is the same. You can't do 0, but you can do 0.1, and that becomes effectively straight line. 6 is the default in this model. And so coming back to the underwriting tab, we can continue then through each one of our line items, right? So we've set the start and end period. We've set the method, whether S-curve, straight line, or detail. Again, if you click detail, you can then just manually enter the cash flows by period. And then we put the amount of each of these line items. So in this case, site work and civil infrastructure, 10.2 million. You move through your land cost, hard costs, soft costs, and that gets you to a project cost before financing. You then enter in, say, a financing fee that is expected to be straight line, most often happens at analysis begin, or perhaps when your construction debt begins to fund. And that completes out our total uses. We then move into our sources of uses, which cover our sources of capital, which cover our total uses. And this model, Arturo has included the ability to do 2 tranches of construction debt. That is entered here, some percentage of the total cost as total construction debt, and then you can break down the ratio between construction and if you have a secondary debt piece, mezz debt or some other secondary debt piece. Let's say that this was at 65%, then you could set this, say, to 60 to 50, and the proportion allocated to the secondary is automatically calculated. You also have the option to choose whether those 2 fund at the same time, or if the construction debt funds first and then mezz comes in second. You also can enter an annual rate. And so this may be floating rate. Think of this as the average rate. We don't yet have in this model the ability to forecast out your variable rate. And so if you're using a variable rate, just assume that this is the average rate across the loan term. You then see out to the right, again, the cash flows for your sources of capital and how those pair to your uses of capital. But as you'd expect, uses and sources equal one another in each period as you would want. Now, this model also includes the auction. While by default, it assumes that you sell at stabilization, you have the ability to add in permanent debt. So click this toggle permanent debt, and that opens up the ability to add a perm debt piece to take out your construction stack. So you'll have some loan funding month, some annual rate. Again, it's assumed to be fixed, or an average of your variable across the loan term, whether there's an interest only or whether it is interest only or not. It does not have the ability to do partial interest only. So it's either all interest only or all amortizing. If it's amortizing, you'll set the period or the number of years to amortize over, and then you'll see monthly payment, monthly payoff, some fee to originate this new permanent debt, and then some basic metrics, percent of LTV on stabilized value, debt service coverage ratio, debt yield in the month following your loan funding month. So that gives you kind of sense as you're sizing your perm debt, that helps you size it to, say, a market coverage, market debt yield, market LTV. Though that is our investment cash flow section. From here, Arturo moves us into an operating cash flow section. This is where we're seeing rental income by each of the tenants. And again, as I mentioned, rent is quoted on a per kilowatt basis. So you'll enter assumptions for each of your tenants. You have the ability to add, it looks like, up to 10 tenants. In the current version of the model, again, I'm showing you beta version 1.2. He has not yet added the ability to add tenants beyond 10. But these tenants are largely the same as industrial, where you have a lease start, some period. But what makes this different, giving a data center, you're going to see the white space concept, the IT load concept, the tenant absorption in kilowatts per month. And so if you have, say, 6,000 kilowatts, this is 15 months to lease up this tenant. There is a rent growth percentage that you can enter here. So by default, we have a placeholder value of 2. And once it is fully leased, then here is your annual rent before any growth for each of the tenants. And then you can also set a recovery percentage. So what percentage of the operating expenses or the pro rata share of the operating expenses does each tenant recover or reimburse the landlord for? And by default, it's set to just a triple net lease, where the tenants are paying 100% of their proportionate share of operating expenses. And then you see some metrics out here to the right, which I won't get into anymore. They're pretty self-explanatory. Now, finally, we have a general vacancy and credit loss factor that you can add that gets us to an effective gross revenue line. We then move into expenses. So kind of typical data center expenses, utility, maintenance, staffing and security, insurance, general administrative, management fee, property taxes. And those are set as an amount per kilowatt per month with some growth rate. And then you can choose what percentage of that is fixed versus variable. So variable, again, if you're 100% variable or 0% fixed and you're 0% occupied, then that line item will be 0. If you're 100% fixed, it doesn't matter how occupied you are. Your line item will be equal to this plus whatever growth is associated with that. And then you might have some blend of fixed versus variable component. Again, these are simply placeholder values. And then property tax, you see a mill rate here, you see some growth rate, And this is just a hard-coded value that you'll enter for property tax at stabilization. Then we have a capital expenditure line item. You have both a CapEx reserve, again, an amount per kilowatt per month, fixed or variable, and then you have the ability to add other capital expenditures that would be added over that would be forecast over time. So you might put, say, 50,000 per year of some other thing. Again, just placeholder, and that would be 50,000 per year plus some growth rate per year. That gets us to both cash flow from operations less any debt service. Now, if there's permanent debt, you're going to see a debt service line item here. What happens if we turn off permanent debt and we assume that we're going to sell just at stabilization? We end at a cash flow from operations line, no permanent debt. And the interest associated with your construction debt is capitalized to your project budget. So it's not shown in the operating expense section. Next, we get to reversion cash flows. This is your exit, your sale. And so again, if there's no permanent debt, you'll see that this stabilizes month 55. And so the placeholder value assumes a sale, say 12 months following stabilization. If you are holding long-term, this might be, say, 120 months, 10-year hold. There's some cap rate today, and then perhaps a cap rate out in the future at sale. They may be different. They may be the same. That's up to you, your market, your underwriting methodology with some selling costs. Now, in my experience today, these placeholder cap rates are much higher than what we're seeing, at least in a lot of the markets that I'm looking at, although this is Panama, and I have no idea what a cap rate on a data center and in this market of Panama would be. Maybe it's higher, given that it's Central America. But in the United States, primary market, these cap rates are going to be higher than that today. But again, you're the expert on your market. You'll know what inputs to put into each of these blue font cells. Then we have a stabilized on an untrended basis and a stabilized on a trended basis pro forma. And that is untrended is going to be as of today. So if you could snap your fingers and this building was fully stabilized, this would be what you're forecasting your net operating income to be. On a trended basis, that is with growing income, growing rents out at stabilization. In that case, it's the first stabilized year of the asset starting in month 55. That's the NOI out into the future. Less some capital expenditures gives you a cash flow from operation. And then we have a sale pro forma. And so if this were to sell in month 67, and assuming that you're pricing off of a forward 12 months, this would be your sale NOI. So again, if we went to, say, permanent debt, we sold out in month 120, now you're looking at a sale pro forma month 120 through month 131, and you've got an NOI of 22. Let me turn this back off so we can continue here. Okay. Then we move, then we get the sale proceeds, right? So the value today on an untrended basis, assuming all the assumptions we made, which are entirely hypothetical, at a 6 cap, NOI of $20.4 million gets you a stabilized value of $340 million, which is pretty good, considering in this very hypothetical, we built this thing for $222 million. And so you're looking at a lift from 222 to 340. But though on a trended basis, and that's because in our trended pro forma, we assume some cap rate erosion, whether right or wrong. That's probably a bit aggressive. Although, again, these are hypothetical, but now you're looking at on a trended basis, you're actually a trended down value. It's usually not what you see in the real world. Usually the cap rate doesn't erode quite this much, although that is 5 years out in the future, so that may or may not be right. Generally, on a trended basis, you're going to see your NOI growing. I think our placeholder growth had income growing at 2%, but expenses growing at a faster rate. And as a result, you see an actual erosion in your NOI. Some expanding of the cap rate results in a trended value out in month 55 of a $312 million. And then sale, again, the sale is pretty close because call it 12 months after stabilization. Then we look into returns. So you can see returns up here in the summary box that Arturo has added, yield on cost, untrended and trended, as well as sale. You compare that to, say, your market cap rates at each of these stages. That gives you your development spread. Again, these hypothetical assumptions, this is quite juicy of a return. You also see equity multiple and IRR. Both of these are property level metrics here. So the property level IRR on an unlevered basis before debt, 14%, after debt, 19.5%, with your multiple on capital, your equity multiple of 2.5, nearly 2.5 on a levered, and 1.75 before debt. And again, you see those calculated and then calculated off here to the right and summarized here. And that then is the conclusion of the property level cash flows. Now, Arturo has not yet added partnership level cash flows. And so that would be your waterfall. Now you can grab any of the equity waterfall models that a.cre has, pull it in here, and then link it over to your net levered cash flow line here, and you could calculate real quickly the contributions from and distributions to each of the partners, as well as their respective returns. So that is Arturo's data center development model. Let us know if you have any questions. Otherwise, thanks for your time.